Take a slow, deep breath in, letting your shoulders drop as you exhale, allowing your entire body to settle into a state of profound rest. We are traveling now to the quiet, meandering course of a freshwater stream, its banks thickly woven with the pale, exposed roots of ancient willow trees, to observe one of nature's most fascinating and joyful creatures, the river otter. Within this tranquil, shaded environment, the North American river otter, known scientifically as Lontra canadensis, goes about its day. What is truly fascinating about these animals is the absolute mastery they possess over their amphibious lifestyle. If you were standing on the mossy bank right now, feeling the cool, damp morning air against your skin, you might suddenly hear a soft, distinct slip of water. An otter has entered the stream, and it does so with almost zero splash or surface resistance. They possess a highly streamlined, torpedo-shaped body that drastically reduces hydrodynamic drag, allowing them to glide through the shifting currents with the fluid grace of a shadow. Let us look closer at that remarkable sleek coat of fur as it breaks the water's surface. If you were to gently run your hand along an otter's back, you would find it incredibly soft, yet wonderfully complex. Here is something most people don't know. Unlike seals, whales, or walruses, river otters do not have a thick layer of blubber to insulate them against the freezing temperatures of glacial streams. Instead, their survival relies entirely on an extraordinarily dense coat of fur. They boast approximately 156,000 individual hairs per square inch of their skin. To put that into perspective, the average human has only about 100,000 hairs on their entire head. This magnificent coat is divided into two distinct, highly specialized layers. The outer layer consists of long, coarse guard hairs. These guard hairs are meticulously coated in natural oils, which the otter produces from specialized sebaceous glands hidden within its skin. Beneath these oily, protective guard hairs lies a remarkably soft, tightly packed underfur. As the otter swims, the oiled guard hairs repel the moisture, effectively trapping a warm, dry layer of insulating air tightly against the otter's body. Even when completely submerged in near-freezing, icy river water, the otter's actual skin never gets wet. You can imagine the supreme comfort of this adaptation, being wrapped in a perfectly tailored, naturally heated suit, feeling the heavy, cold pressure of the river on the outside, while remaining completely warm, dry, and cozy inside. As our otter glides silently beneath the surface, navigating the submerged architecture of ancient tree roots and smooth, river-worn stones, it relies on a fascinating array of sensory tools. Notice the long, stiff whiskers protruding from its muzzle. These are not merely decorative hairs. These whiskers, scientifically called vibrissae, are highly sensitive tactile organs, each one rooted deeply into a dense network of nerve endings. They act as an incredibly precise underwater radar system. The vibrissae can detect the most minute changes in water pressure and subtle hydrodynamic currents. If a small silver fish darts away in the murky emerald depths, the otter does not even need to see it. The vibrissae feel the physical ripples left behind in the water column, allowing the otter to follow an invisible, lingering aquatic trail through the dark. But when they do open their eyes, their vision is an engineering marvel. If you have ever opened your own eyes underwater without swimming goggles, you know the world appears incredibly blurred and distorted. This occurs because the human cornea is designed to focus light as it passes through the air, not through dense liquid. Otters, however, possess a specially adapted, highly curved lens and cornea that physically correct for the refraction of water. This evolutionary adjustment grants them crystal clear vision beneath the surface. Furthermore, as they dive down into the depths, a specialized, transparent third eyelid, known as a nictitating membrane, sweeps smoothly across their eye. This thin membrane functions exactly like built-in swimming goggles, protecting the delicate ocular tissue from floating silt and debris while maintaining absolute visual clarity. The sensory mastery of the river otter extends even further to their ears and nose. When an otter decides to plunge deeper, sliding down toward the sandy bed of the stream, specialized muscular valves located in both their ears and their nostrils automatically snap shut. This creates a flawless, watertight seal, preventing even a drop of water from rushing in. Imagine the quiet, muffled hush that falls over your own ears when you submerge yourself in a warm bath, the sudden softening of the world's noise. For the otter, this silent, pressurized, gravity-free world is their daily playground, and they can stay in this peaceful underwater realm for an astonishingly long time. A river otter can hold its breath for up to 8 minutes on a single deep gulp of air. They achieve this remarkable feat through a specialized circulatory system that intentionally slows their heart rate down, a process known as bradycardia, conserving valuable oxygen as their body relaxes into the glide. Watching an otter maneuver through the water is a mesmerizing lesson in fluid dynamics. They propel themselves forward using a thick, highly muscular tail. This tail, which makes up a full 1/3 of their entire body length, acts as a powerful, flexible rudder. It is thickest at the base and tapers elegantly to a point, weaving from side to side in a rhythmic, undulating motion that perfectly mirrors the natural, serpentine flow of the river itself. Their feet, too, are perfectly adapted. They possess fully webbed toes, catching the water like paddles for rapid propulsion. Yet, despite this webbing, their paws remain incredibly dexterous. On land, those same sensitive toes can manipulate tiny pebbles, investigate the texture of fallen leaves, or playfully juggle smooth river stones with surprising coordination. This brings us to one of the most delightful and thoroughly studied aspects of Lontra canadensis, their curious, seemingly endless drive to play. In the wild, play is rarely just for simple amusement. It is a vital, functional evolutionary tool. If you observe the muddy banks closely, you might see an otter engaging in a fascinating behavior biologists call tobogganing. The otter will find a slick patch of wet river mud, a damp layer of thick moss, or a soft slope of fresh snow. They tuck their front paws tightly against their chest, push off with their hind legs, and slide down the bank head first, gliding effortlessly until they splash softly into the stream. While it looks like an expression of pure, unadulterated joy, and neurochemically, it does flood their brains with highly rewarding endorphins, tobogganing is actually a brilliant method of energy conservation. By sliding on their smooth bellies over frictionless surfaces, otters can travel across land much faster, and by expending significantly fewer calories than if they were walking or bounding. Energy conservation is a remarkably serious matter for river otters because their internal engines run incredibly fast. They possess an exceptionally high basal metabolic rate. This internal furnace is absolutely necessary to generate the constant body heat required to survive in their chilly aquatic habitats. What is truly fascinating about this metabolism is how quickly it processes fuel. An otter's digestive system is so efficient that food passes entirely through their digestive tract in just about 1 hour. This rapid internal turnaround means an otter must consume roughly 15 to 20% of its total body weight every single day, just to maintain its warmth and energy. This high energy demand perfectly explains why their bodies are so finely optimized for efficient movement, turning a simple muddy hill into a high-speed, calorie-saving transit system. Even when they are resting on the bank, otters remain deeply connected to one another through an intricate and rich vocabulary of sounds. Even over the rushing, bubbling white noise of the river, their distinctive vocalizations carry through the air. They do not merely squeak, they emit a wide, expressive variety of sounds. You might hear low-frequency, comforting chuckles, gentle, rumbling grunts, and a soft, rhythmic chirping that sounds surprisingly similar to a flock of small sparrows. When they need to call out to a family member over a vast distance, they can produce a high-pitched, piercing whistle. This specific frequency is so perfectly tuned to its environment that it can be heard up to a full mile away across the flat, reflective surface of a quiet lake or wide river. These sounds vibrate gently through the crisp morning air, weaving seamlessly into the acoustic landscape of the rustling willow leaves and the steady flow of water. After a long period of swimming, foraging, and tobogganing, an otter's routine inevitably turns to rigorous, meticulous grooming. This is not an act of vanity, but an essential survival ritual. Every single time an otter finishes a meal or leaves the water, it must immediately tend to its thick coat. They will find a dry patch of earth and roll vigorously in soft sand, tall grass, or a bed of fallen pine needles. This behavior, which provides a deep, satisfying tactile pressure against their skin, serves a critical biological function. The dry earth and grass act like a towel, absorbing excess moisture from their outer guard hairs. The rolling motion also helps realign the complex, interlocking microscopic structures of their fur, fluffing up the dense undercoat to perfectly restore that vital, invisible layer of trapped, insulating air. When the grooming is complete and the otter is warm and dry, it will often retreat to its den, known as a holt. Here is another fascinating fact about their ecology. Otters rarely dig their own homes from scratch. Instead, they are highly opportunistic inhabitants. They seek out abandoned beaver lodges, or they discover natural, spacious hollows formed beneath the deeply entangled root systems of massive riparian trees. Inside these sheltered holts, they construct soft, comfortable nests, thoughtfully lining the earth with dry leaves, fresh green moss, and soft grass. Most ingeniously, a proper holt usually features a hidden underwater entrance. Imagine the profound safety of that design. The otter glides through the cool, flowing river, swimming deep beneath the surface, only to slip into a submerged, sloping tunnel of damp earth. As they swim upward through the dark passage, they gradually rise above the waterline, emerging into a pitch-black, warm, completely dry chamber, filled with the rich, soothing scents of dried moss, damp river clay, and safety. The air inside this enclosed space is continually warmed by the otter's own radiating body heat, creating a tiny, perfectly insulated microclimate, entirely shielded from the winds and weather of the outside world. Within this dark, secure haven, the otter curls its long, flexible body into a perfect circle, wrapping its thick tail over its nose, and settles into a state of absolute, undisturbed peace. Deep within that perfectly insulated holt, as the otter sleeps peacefully curled in a tight circle, we can step back to examine this creature through the long, winding lens of history. Allow your mind to drift backward in time, moving far beyond the current century, to understand how long these remarkable animals have navigated the world's waterways. The story of the North American river otter begins deep in the geologic past. Paleontologists note that the genus Lontra diverged from other otter lineages approximately 5 to 7 million years ago during the Miocene epoch. Throughout this immense stretch of time, their physical form has been meticulously shaped by the slow, deliberate forces of evolution. Notice how perfectly engineered their skeletal structure is for their specific lifestyle. By examining ancient fossil records, scientists discovered that these early otters developed an unusually short rostrum or snout, alongside a significantly expanded brain case. This larger cranial capacity did not evolve by accident. It specifically accommodates the expanded somatosensory cortex, necessary to process the massive amounts of complex tactile information streaming in continuously from their sensitive facial whiskers. Long before European science formally categorized the species, indigenous populations possessed a profound, intimate understanding of their ecology. The Algonquian-speaking peoples of North America, specifically the Ojibwe, observed these creatures carefully as they moved through the vast network of continental lakes and rivers, naming the river otter Nigig. Early Native American cultures recognized the otter's immense historical range, which originally spanned almost the entirety of the continent, stretching uninterrupted from the warm waters of the Rio Grande all the way north to the freezing ice-locked rivers of the Alaskan Arctic Circle. Historical records reveal that it was not until the year 1776 that the German naturalist Johann Christian Daniel von Schreber formally described the species in Western scientific literature, publishing his detailed observations in his multi-volume masterwork, Die Säugetiere in Abbildungen nach der Natur mit Beschreibungen. Decades later, during the famous expedition of 1804 to 1806, explorers Meriwether Lewis and William Clark encountered these vibrant creatures. Picture the soft yellow glow of a lantern in a canvas tent, where Meriwether Lewis, using a quill pen, documented the sliding behaviors of otters along the muddy banks of the Missouri River, captivated by their constant, energetic motion. For generations, early 19th century naturalists firmly dismissed this sliding and wrestling as mere utilitarian locomotion. They believed nature was far too harsh to allow for frivolous activities. It took nearly 2 centuries for scientific thought to shift. Propelled by the groundbreaking work of modern ethologists like Robert Fagan, who published the comprehensive text Animal Play Behavior in 1981, the scientific community finally accepted a beautiful truth. Animals actively engage in play, not just to move from place to place, but for vital neurological development, physical conditioning, and profound social bonding. Consider how early trappers and woodsmen gradually uncovered the invisible, highly complex communication networks established by these animals. River otters do not rely solely on vocalizations. They use specialized anal glands to mark their territory with a substance known as spraint. While the idea of a territorial marking might suggest a foul odor to human sensibilities, early naturalists repeatedly noted a surprising sensory detail. Otter spraint possesses a distinctly non-foul, sweet, and musky aroma. Observers have often compared the scent to the smell of freshly mowed hay, drying in the summer sun, or even a dense patch of blooming purple violets hidden in the damp woods. Otters deposit these fragrant markers at specific communal locations, known as latrines. Consider the communal latrine not as a simple trampled clearing on a riverbank, but rather as an elaborate olfactory library. Each scent mark acts like a beautifully bound volume of biological autobiography, left open on a mossy shelf for the next visiting otter to read. By simply sniffing these markers, an otter passing through the territory can instantly determine the age, sex, diet, and reproductive status of their neighbors, creating a rich, invisible tapestry of community information layered over the physical landscape. The reproductive cycle of the river otter was, for a very long time, a baffling mystery to early biologists. Female river otters typically mate in the late winter or early spring, as the ice begins to fracture and thaw. Yet, historically, observers could not understand why the young were not born until nearly a year later. Scientists eventually discovered a remarkable biological phenomenon known as embryonic diapause, or delayed implantation. After fertilization, the egg develops into a tiny cluster of cells called a blastocyst, and then entirely halts its growth. It floats freely within the uterus, remaining completely dormant for an astonishing 8 to 10 months. Picture this microscopic sphere of life suspended in perfect stillness, patiently waiting out the changing seasons, the heat of summer, and the falling leaves of autumn. Once the environmental conditions align and the daylight begins to lengthen the following winter, the embryo finally implants in the uterine wall. From that exact moment, the true gestation period is incredibly brief, lasting only 60 to 63 days. This highly strategic delay ensures that the pups are always born in the mild, welcoming days of early spring, precisely when fish populations are surging and the mother has abundant resources to produce nutrient-rich milk. At birth, the physical reality of the pups directly contradicts their future as masters of the water. They are born utterly blind, completely toothless, yet fully covered in a silky dark coat of fur. A newborn river otter weighs a mere 5 ounces, or approximately 130 grams. They rest together in the quiet, earth-scented darkness of the Holt, completely dependent on the rhythmic, soothing heartbeat and warmth of their mother. Perhaps the most charming paradox recorded by early animal handlers and wildlife rehabilitators is that river otter pups are not born knowing how to swim. Despite their aquatic destiny, they possess an inherent aversion to the water. At around 2 months of age, when the pup's eyes are fully open and they have grown stronger, the mother must initiate their education. She will gently but firmly grasp the pups by the scruff of their necks and physically drag them down the muddy bank, easing them into the cool, shallow ripples of the stream. At this early stage, their natal coat is so thick and dense, with trapped insulating air, that the pups are highly buoyant. They float on the surface of the water like weightless, furry corks, bobbing gently in the current. Because of this extreme buoyancy, a young pup is physically incapable of diving beneath the surface. They must wait several weeks to shed this specialized baby fur and grow their sleeker adult coat before they can follow their mother down to the sandy riverbed. Once fully grown, the spatial requirements of these animals become staggering. Early land surveyors and naturalists struggled to accurately map their movements because a single male river otter's home range can cover an immense distance. Their territory can stretch up to 50 linear miles, or 80 kilometers, along a branching network of streams, wetlands, and lakes. To navigate and patrol this massive expanse, an otter cannot rely on a single home. Within that 50-mile stretch, an individual otter might establish and actively maintain 30 to 40 distinct resting sites, moving fluidly between different holts as they travel up and down the watershed. Historical stomach content analyses, conducted extensively in the early 1900s, revealed that their role in shaping these 50-mile ecosystems is deeply balanced. Early ecologists learned that otters are highly opportunistic foragers. Rather than hunting the fastest game fish, they often focus their energy on slower-moving, abundant species like carp, suckers, and large amphibians, or use their incredible dexterity to flip river stones in search of crayfish. As they crunch through the hard, calcified exoskeletons of those crayfish, a specific anatomical feature comes into play. Comparative anatomists studying historic skeletal specimens documented that the otter's mandibular fossa, the exact point where the lower jaw hinges against the skull, is deeply C-shaped. This specialized curve effectively locks the jaw joint securely in place, completely preventing the mandible from dislocating sideways when the otter applies immense bite force to a hard, slippery shell. Through the careful study of captive individuals in historically sheltered, enriched environments, biologists learned the true potential of their longevity. While a wild otter navigating the rigors of the natural watershed might average an 8 to 9 year lifespan, historical records from protected sanctuaries document river otters living peacefully for up to 21 years. To ensure these creatures continue to weave their way through the fabric of the natural world, conservationists have looked to history to guide the future. Recognizing the historical depletion of the species from their original continental range, modern biologists initiated massive reintroduction programs beginning in the 1970s. Through meticulous planning and ecological tracking, conservation teams successfully relocated river otters to 21 different states across the American Midwest and beyond. By carefully moving these animals into protected, revitalized waterways, science has actively restored the ancient genetic diversity of the species, allowing their joyful sliding descents and their sweet violet-scented markers to return to the quiet shaded banks of the rivers once again. Resting upon the quiet shaded banks of the river, the otter embodies a perfect harmony of biological engineering. Deep within the biology of these magnificent animals lies an internal architecture as thoughtfully designed as any modern home. Think of the river otter's core anatomy not merely as flesh and bone, but as a perfectly insulated, self-sustaining submarine, equipped with highly specialized life support systems meant to conquer an uncompromising aquatic world. Consider their incredible thermal regulation. An adult river otter maintains a constant, roaring core body temperature of exactly 100 degrees Fahrenheit, or about 38 degrees Celsius. Remarkably, they can comfortably forage in glacial runoff, where the water temperature plunges to a bitter 34 degrees Fahrenheit, or just 1 degree Celsius. To survive this immense differential, their bodies function much like carrying a sealed, roaring fireplace inside a heavy-duty thermos. They lose almost no internal heat to the surrounding chill. What's happening now, as the otter wades into the cool shallows, is a hidden marvel of vascular plumbing known as the rete mirabile, or wonderful net. In their uninsulated paws and tail, their arteries and veins are interwoven in a dense, side-by-side microscopic mesh. Imagine two water pipes running perfectly parallel under the floorboards of a house, one carrying freshly heated water from the boiler, the other returning chilled water from the outside. As warm, oxygen-rich arterial blood travels down toward the cold paws, its heat transfers directly across the vessel walls into the cold venous blood, returning to the heart. This built-in thermal radiator ensures their core remains eternally warm, while their extremities receive just enough circulation to prevent freezing. Notice how the otter prepares for a prolonged dive, drawing in a massive expanding breath. If we look at their respiratory system, it is fundamentally different from ours. Instead of two simple lung cavities, the right lung of a river otter is divided into 4 highly specialized lobes: the cranial, middle, caudal, and accessory lobes. Their left lung contains 2. Think of their chest cavity like a carefully packed, multi-compartmental hiking backpack, rather than a single open sack. This complex lobular structure allows for incredibly efficient gas exchange, maximizing every single molecule of inhaled air before they slip beneath the current. To sustain those long 8-minute submersions, they do not rely solely on their lungs. Scientists discovered that river otters possess exceptionally high concentrations of a vital protein called myoglobin within their muscle tissue. Myoglobin binds and stores oxygen locally, directly within the skeletal muscle. You can picture these myoglobin proteins as millions of microscopic scuba tanks or tiny pre-charged chemical batteries embedded seamlessly into their chest and legs. Where even when their lungs are completely empty of air, their muscles can continue pulling on these localized oxygen reserves to power their graceful underwater spirals. Furthermore, their overall blood volume is significantly elevated compared to land-dwelling mammals. Blood accounts for a full 9 to 10% of a river otter's total body weight. This expanded internal reservoir functions like an oversized fuel tank on a long-haul vehicle, guaranteeing that vital oxygen is continually shuttled to the brain, even during the most strenuous, twisting aquatic maneuvers. At this very moment, watching an otter move across a fallen, moss-draped log reveals another mechanical wonder. Up to 40% of a river otter's entire body weight is composed of pure, dense, skeletal muscle. This extraordinary ratio is comparable to the lean muscle mass of an elite Olympic gymnast. Because of this dense musculature, they are surprisingly heavy for their sleek size, a physical trait that helps them easily overcome the natural buoyancy of water. When they transition from swimming to running along the forest floor, their locomotion shifts into a distinctly rhythmic pattern. They utilize a specialized bounding gait, often described by biologists as a 3x3 gallop. As they run, they push off simultaneously with both hind legs, arching their long spines into a profound curve before landing on their front paws. The motion is incredibly fluid, much like a tightly coiled mechanical spring, continuously compressing and releasing over the uneven, root-tangled terrain. Deep within their skeletal frame, nature has provided them with an ingenious form of built-in ballast. Through a biological phenomenon known as pachyostosis, the bones of a river otter's skull are unusually thick and solid compared to other mammals of similar size. Think of this heavy cranial bone like the weighted lead keel at the very bottom of a sailboat's hull. It provides vital anterior weight, helping the otter naturally angle its head downward to scan the muddy river bottom without expending extra swimming energy just to stay submerged. As they investigate the riverbed, turning over smooth stones and probing submerged logs, their paws utilize specialized tools. Unlike house cats, river otters possess non-retractable claws. Because they are constantly exposed and used for digging, these claws are relatively short, thick, and naturally blunted by the friction of river stones. They function perfectly as well-worn gardening trowels, unsuited for slicing, but beautifully shaped for excavating hidden roots or dislodging stubborn freshwater mussels from the silt. Freshwater mussels, categorized within the class Bivalvia, are a staple of the otter's diet. To process the hard, jagged edges of crushed mussel shells and sharp fish bones safely, their digestive system relies on specialized salivary glands. These glands produce copious, continuous amounts of incredibly thick, viscous saliva. This biological fluid acts precisely like heavy-duty engine oil or an organic lubricant, heavily coating the sharp fragments of their meals so they slide smoothly down the esophagus, without snagging or scratching the delicate internal tissues. Processing the massive electrolyte load from an aquatic diet requires tremendous internal filtration. For this, the otter utilizes specialized reniculate kidneys. Unlike a human kidney, which resembles a smooth, uniform bean, an otter's kidney is multi-lobed, looking very much like a tight, dark red cluster of grapes. Each tiny lobe functions as its own independent filtration unit. You might compare this organ to a massive industrial water filtration plant, utilizing multiple simultaneous processing tanks, capable of clearing immense amounts of metabolic waste with staggering efficiency. Consider their sensory apparatus, which functions like a suite of highly tuned electronic instruments. While we admire the peaceful quiet of the forest, the river otter is actively listening to an acoustic world we cannot even perceive. A river otter can detect high-frequency sounds up to 45,000 hertz, or 45 kilohertz. To put that into perspective, the absolute upper limit of human hearing is only about 20 kilohertz. The otter is constantly tuning into a high-definition radio station, broadcasting entirely on a frequency we lack the biological antenna to receive, catching the ultrasonic squeaks of small mammals hidden in the tall grass. Their facial whiskers operate with equally stunning mechanical precision. Rather than being loosely rooted in the skin, each individual vibrissa is attached to its own dedicated complex muscle group. This structural arrangement is much like the inner workings of a grand piano, where every single ivory key is physically connected to its own precisely tuned, independent hammer. The otter can individually pivot and angle specific whiskers to perfectly map the three-dimensional currents swirling around them. Picture this scene as twilight begins to settle over the waterway, casting long purple shadows across the surface. If a sliver of moonlight catches an otter's eye, you will witness a bright glowing reflection. This is due to the tapetum lucidum, a specialized reflective layer situated entirely behind the retina. It acts exactly like a built-in rearview mirror. As faint ambient starlight passes through the eye, it hits this mirror-like membrane and bounces back through the photoreceptor cells a second time. This ingenious anatomical loop grants the otter a second chance to absorb scarce light particles, providing brilliant night vision in the murky depths. Even when the otters have moved on, drifting lazily downstream to another resting site, they leave behind clear physical artifacts of their presence. Tracing their steps along the soft, damp clay reveals a highly distinctive footprint. Otter tracks are almost exactly 3¼ inches wide, or about 8.3 centimeters, displaying 5 distinct, splayed toes. Often, the prints of their hind feet perfectly overlap the prints of their front feet, creating a pattern that looks very much like overlapping ink stamps carefully pressed into a passport. Along the banks, you will often find neat, accumulated piles of those discarded freshwater mussel shells, which ecologists refer to as middens. Finding an otter midden tucked under a weeping willow tree is much like discovering a stack of smooth or iridescent ceramic plates left neatly on a table after a sprawling family feast. These middens slowly break down over decades, leaching vital calcium back into the riparian soil. If you are extraordinarily lucky, you might observe an otter sitting quietly near one of these middens, engaging in a deeply fascinating solo activity, juggling small, smooth river stones. They will lie on their backs and rapidly pass a polished pebble back and forth between their incredibly dexterous front paws. Scientists discovered this behavior is not just idle play. It actively hones their fine motor skills and maintains critical neural pathways. Much like a concert musician, absent-mindedly running through complex scales to keep their fingers nimble, the otter is silently practicing its craft, keeping its physical instruments perfectly tuned for the endless, joyful rhythm of the river. Watching the rhythmic, graceful movement of the river otter offers a profound perspective on how deeply intertwined life truly is, reflecting patterns that resonate powerfully with our own human experience. As we trace the intricate pathways these animals weave through the landscape, we begin to uncover a grander ecological narrative. The otter is not simply a charming inhabitant of the stream. It functions as a keystone species, a biological anchor whose presence stabilizes the entire surrounding ecosystem. Think of a massive, vaulted stone archway holding up the ceiling of a grand cathedral. If you were to gently remove the center keystone, the entire structure would slowly begin to sag and crumble. To understand this immense influence, we must look at their role in maintaining the health of the fish populations they depend upon. You might assume that a skilled predator would deplete the waters, but the reality of nature's calculus is beautifully counterintuitive. Biologists conducting longitudinal studies have documented that river otters engage in a practice known as compensatory predation. Because they are highly opportunistic and seek out the easiest meals to conserve their rapidly burning calories, otters disproportionately target fish that are old, slow, or perhaps compromised by illness. By naturally culling the weakest individuals from a school of carp or suckers, otters inadvertently ensure that only the strongest, healthiest fish remain to reproduce. This ongoing, gentle pressure prevents the spread of aquatic diseases and actively strengthens the genetic vitality of the entire river system over generations. Look closely at the water chemistry itself to see their hidden impact. The sheer act of an otter swimming and rolling through the shallow mudflats performs a vital ecological service known as bioturbation. When a 20-pound adult river otter aggressively churns the silty bottom to unearth a hidden crayfish, they are physically mixing the sediment. This vigorous mechanical stirring releases long-trapped organic nutrients, particularly phosphorus and nitrogen, back up into the water column. These essential compounds then become immediately available to microscopic phytoplankton. The sudden bloom of these tiny plants pulls vital oxygen into the water, feeding the aquatic insects that, in turn, sustain the whole food web. The otter's playful splashing is quite literally breathing life back into the river. In this way, the health of the waterway is directly mirrored in the physical condition of the otter. Ecologists refer to the river otter as a bioindicator species. Because they occupy the very top of the aquatic food chain, any subtle shifts in environmental health, such as fluctuations in water purity or the decline of a specific fish species, are immediately reflected in the otter's population density and overall wellness. You can think of them as nature's most sophisticated, living water quality testing kits. When we see a family of otters joyfully tobogganing down a muddy slope, it is a definitive, scientifically verifiable sign that the surrounding watershed is robust, thriving, and chemically pure. We can also observe a beautiful reflection of human social structures within their complex family units. While adult males often lead highly solitary lives, traversing their massive 50-mile territories alone, the females establish deep, enduring maternal bonds. A mother otter does not simply birth her pups and leave them to instinct. She actively educates them for nearly a full year. This extended period of maternal investment is one of the longest in the animal kingdom for a mammal of their size. It reveals a sophisticated level of social learning. The mother must physically demonstrate exactly which rocks harbor crayfish, how to properly open a mussel shell, and the safest routes through the labyrinth of underwater roots. It is a slow, patient transfer of generational knowledge, being passed down quietly through the dappled shade of the willow trees. Within these familial groups, conflict is exceedingly rare. managed through an elaborate system of mutual grooming called allogrooming. When two otters meet on a sun-warmed rock, they will often spend hours gently nibbling and combing through each other's thick underfur. This repetitive, deeply tactile behavior triggers the release of oxytocin in their brains, the exact same neurochemical that floods our own human systems when we hug a loved one or pet a dog. This physical closeness serves a dual purpose. It perfectly maintains the waterproof integrity of their coats in areas they cannot easily reach themselves, and it profoundly reinforces their social bonds, ensuring peaceful cooperation within the territory. As they move seamlessly between land and water, otters rely on highly specialized guard hairs, known scientifically as pelage. When you step out of a swimming pool, your hair immediately clumps together, heavy with retained water. The otter's pelage operates on a completely different physical principle. The outer guard hairs feature microscopic, interlocking spikes, much like tiny organic zippers. When the otter submerges, these zipper-like structures lock tightly together, sealing out the moisture. But the moment they emerge onto the dry bank and give a vigorous full-body shake, those microscopic zippers instantly unlock. This allows the water to sheet off their bodies in a single, rapid spray. They can go from being completely submerged to almost entirely dry in a matter of seconds. Reflect upon the incredible elasticity of their biology. An adult river otter possesses a highly flexible, elongated vertebral column composed of roughly 66 individual vertebrae, depending on the specific subspecies. For comparison, the human spine contains only 33. This vast number of separate articulating joints provides them with a nearly liquid, serpentine flexibility. They can physically bend their bodies into a complete U-shape, touching their nose to the base of their tail without straining a single muscle. This extreme flexibility is absolutely essential for navigating the tight, twisting subterranean tunnels of abandoned beaver lodges where they make their holts. Even their resting heart rate demonstrates a profound adaptability to their changing environments. While comfortably asleep in their dark, earthen dens, a river otter's heart beats at a steady, rhythmic pace of around 130 to 170 beats per minute. Yet, the moment they plunge into the freezing current, that rate can plummet to exactly 10% of its normal speed. This instantaneous cardiovascular shift, known as the mammalian dive reflex, is a breathtaking feat of autonomic control. Imagine having the ability to consciously command your own heart to slow to a mere crawl, entering a state of profound chilled suspension while you smoothly navigate a high-pressure environment. To endure the harsh, unpredictable fluctuations of the changing seasons, river otters do not hibernate. Unlike bears or groundhogs that seek refuge in long winter sleeps, the otter remains fiercely, joyfully active all year round. During the deep freeze of midwinter, when the surface of the lakes and wide rivers locks solid under a thick sheet of ice, they simply alter their tactics. They will actively seek out the narrow, fast-flowing bottlenecks of the stream, where the rapid current prevents the water from freezing over, or they will locate tiny, natural air pockets trapped between the frozen ice sheet and the fluctuating water level below. Underneath this frozen ceiling, the otter maneuvers in complete, frigid darkness. They rely heavily on a specialized layer of fat, distinct from blubber, known as brown adipose tissue. This specific type of fat is densely packed with mitochondria, the microscopic powerhouses of the cell. In human infants, brown fat exists to generate warmth without shivering. In the adult river otter, this tissue acts like an internal, continuously burning furnace, directly converting stored calories into radiant heat to keep their core at that vital 100 degrees Fahrenheit, even as they swim beneath 2 feet of solid, opaque ice. Observe how their daily routines are dictated not by the arbitrary numbers on a clock, but by the subtle shifting availability of light. Biologists classify river otters as crepuscular creatures, meaning their peak periods of activity occur precisely at the soft, transitional hours of dawn and dusk. This schedule is a masterstroke of evolutionary strategy. By hunting when the light is low and scattering across the surface of the water, they avoid the harsh glare of the midday sun, utilizing their highly specialized tapetum lucidum to its maximum advantage. In doing so, they exist perpetually in the quiet, peaceful margins of the day. When we consider the full scope of their existence, the complex delayed rhythm of their reproduction, the slow transfer of generational wisdom, and the vital breathing impact they have on the water itself, we see a picture of absolute unbreakable connection. They remind us that nothing in the natural world operates in isolation. The simple, joyful slide of an otter down a muddy bank is intimately tied to the microscopic bloom of phytoplankton, which in turn secures the very oxygen within the river. By understanding the deep, hidden mechanics of the river otter's life, we gain a quieter, more profound appreciation for the intricate living tapestry that surrounds us all. Examine the soft, dappled light filtering gently through the green canopy of the overhanging willow trees, casting golden ripples onto the surface of the stream. To comprehend exactly how the river otter perceives this peaceful, sunlit environment, we must explore the fascinating cellular structure of their eyes. Scientific analysis of the retina reveals that river otters possess dichromatic vision. Unlike humans who rely on 3 types of color receptor cells, otters completely lack the specific photoreceptor cones necessary to process the color red. This is an exquisite biological adaptation driven entirely by the physics of water. Because water naturally absorbs longer red light wavelengths within the first few meters of depth, red colors practically disappear in aquatic environments. By prioritizing blue and green photoreceptors, the otter's eyes are perfectly calibrated to gather the most abundant, useful light waves, painting their visual world in cool, soothing shades of rich amber, deep emerald, and soft azure. Investigate the complex, layered scent profile of the damp riverbank, the mingling, earthy aromas of wet clay, decaying pine needles, and sweet, blooming water lilies resting on the calm eddies. When the otter lifts its head and draws a deep, deliberate breath, it pulls these airborne molecules into a highly intricate labyrinth of bone, known as the nasal turbinates. These fragile, deeply convoluted scroll-like bony structures are tightly packed within their snout. Their primary function is to exponentially increase the internal surface area covered by olfactory receptors. As the cool, humid air swirls through these damp, intricate passages, the invisible scent particles are physically slowed down and trapped by the mucosal lining. This process allows the brain's olfactory bulb to meticulously decode incredibly faint, complex chemical signatures drifting on the breeze, providing a detailed, invisible map of the surrounding wetlands. At the base of each long, stiff facial whisker lies another marvel of sensory engineering, an anatomical structure known as the follicular sinus complex. Instead of resting firmly in solid tissue, the root of every single vibrissa is suspended within a tiny, specialized capsule that is entirely filled with blood. You can picture this fluid-filled chamber as a highly sensitive, microscopic hydraulic amplifier. When a faint, shifting underwater current simply brushes the tip of the whisker, That tiny mechanical movement travels down the stiff hair shaft and physically displaces the fluid within the sinus. This microscopic ripple of liquid intensely magnifies the signal, pressing firmly against a dense, surrounding ring of highly responsive nerve endings. This explains precisely how an otter can detect the microscopic pressure waves left behind by a drifting leaf, even in completely opaque, mud-clouded waters. Their bare paw pads are similarly equipped to decode the tactile world with stunning precision. Deep beneath the dark, leathery skin of their toes, neurobiologists have identified an extraordinarily high density of Meissner's corpuscles. These are highly specialized sensory mechanoreceptors, explicitly designed to detect light touch and low-frequency vibrations, specifically those pulsing between 10 and 50 hertz. As the otter rests its wet paws upon a submerged mossy stone, these corpuscles fire continuously. They send a rapid, richly detailed stream of textural data. The slippery slickness of green algae, the coarse, rough grit of river sand, and the smooth, polished curve of a buried pebble, straight to the somatosensory cortex for immediate processing. To safely process the varied, textured foods they forage with those sensitive paws, biologists have carefully mapped the specific dental formula of Lontra canadensis. An adult river otter possesses precisely 36 teeth. While they have sharp canines for grasping, the most remarkable feature lies in their posterior teeth, scientifically classified as bunodont molars. Unlike the strictly carnivorous felines that rely entirely on sharp, slicing carnassial teeth, the otter's molars feature broad, relatively flat crowns topped with smoothly rounded cusps. The reason for this specific architecture lies in the mechanical physics of their diet. Because they regularly consume hard-shelled crustaceans and aquatic invertebrates, they require a heavy crushing surface rather than a delicate shearing blade. These flattened molars allow the jaws to exert immense, localized pressure directly onto a hard shell, smoothly fracturing it without risking damage to their own vital tooth enamel. Deep within their digestive tract, a specialized microscopic ecosystem works tirelessly to support this rich aquatic diet. Microbiologists analyzing the gastrointestinal systems of river otters have sequenced highly specific communities of symbiotic gut bacteria, overwhelmingly dominated by microbial phyla, such as firmicutes and proteobacteria. Because the digestive transit time in an otter is so incredibly rapid, completing its cycle in barely an hour, they lack the biological luxury of slow, lengthy fermentation. Instead, these highly specialized bacteria are programmed to rapidly secrete massive concentrated volumes of lipases and proteases. These powerful enzymes immediately break apart the complex proteins and dense, oily fats found in fresh fish, ensuring that maximum caloric energy is absorbed swiftly and safely into the bloodstream. It is curious to note how the sensory environment physically interacts with and alters their appearance as the seasons gently turn. When a river otter molts and grows its fresh adult coat in the late autumn, the thick fur is typically a rich, glossy, dark mahogany, appearing almost completely black when wet. However, as the long, warm days of spring and summer expose them to hours of bright sunshine, a distinct chemical shift occurs on a cellular level. The sustained ultraviolet radiation from the sun slowly degrades the dense melanin pigments embedded within the tips of the outer guard hairs. By the end of August, the top layer of their fur is beautifully and naturally sun-bleached. It fades to a warm, toasted cinnamon brown, giving their coat a soft, frosted texture that blends seamlessly with the rustling, dried reeds along the sun-baked river margins. Watch the specific, powerful way They propel themselves when they wish to cross a wide, calm stretch of open water. To maximize their speed, they often utilize a rhythmic, undulating swimming technique known to hydrodynamic researchers as porpoising. They launch their sleek bodies completely out of the water in a smooth, continuous arc, plunging flawlessly back into the depths a few feet ahead. The mechanical efficiency of this motion is governed by a principle of fluid dynamics represented by the Strohal number. This dimensionless mathematical equation describes the efficiency of oscillating flow. Remarkably, otters naturally adjust the exact frequency of their tail kicks and the amplitude of their body waves to maintain a constant Strohal number between 0.2 and 0.4. In the science of aerodynamics and hydrodynamics, this specific numerical range is the absolute sweet spot where forward thrust is maximized and energy drag is perfectly minimized. To power this incredibly efficient, undulating motion, they employ a muscular action known as dorsoventral flexion. The massive epaxial muscles, which run thick and heavy along the entire length of their spine, contract and release in a powerful, synchronized wave. This up and down, dolphin-like undulation is fundamentally distinct from the side-to-side swimming motion utilized by most fish and aquatic reptiles. This specialized vertical flexing of the spine allows the river otter to generate sudden, smooth bursts of speed. It propels them effortlessly through the cool, drifting currents at speeds reaching up to 7 miles per hour, or 11 kilometers per hour, parting the water with absolute silent grace. Every single aspect of their biology, from the blue-green preference of their dichromatic retinas to the microscopic hydraulic chambers surrounding their whiskers, operates in flawless harmony. Their bodies are continuously receiving, interpreting, and responding to the quiet, subtle symphonies of the river. They are wholly immersed in a world of cool temperatures, rich scents, and complex textures, navigating the gentle flow of the watershed with an innate, scientifically perfected serenity. As the late afternoon sun gradually dips below the horizon of the wetland, a highly orchestrated sequence of biological events begins to unfold, bringing the vibrant activity of the river otter to a peaceful, comforting halt. We can observe this transition as a meticulous, step-by-step process of winding down. It starts with the subtle, shifting physics of light. As the sun sets, the ambient illumination, measured scientifically in units called lux, steadily drops. The specialized retinal ganglion cells within the otter's eyes instantly detect this fading light and send a direct chemical signal deep into the brain, targeting a tiny structure known as the suprachiasmatic nucleus. This specific cluster of neurons acts as the master biological clock. Once activated by the gathering dusk, it instructs the pineal gland to begin synthesizing and releasing the hormone melatonin into the bloodstream. For the crepuscular river otter, the slow, steady accumulation of melatonin initiates a gentle cascade of physiological changes. The hormone acts as a systemic messenger, gradually lowering their core body temperature by just a fraction of a degree, preparing their cellular metabolism for a period of sustained rest. The next stage of this winding down process involves a deliberate grooming session before retiring. As the otter pulls itself from the water onto the dark, damp earth of the riverbank, it must thoroughly prepare its coat for the night. The sequence is precise. First, the otter rapidly shakes its body, using centrifugal force to physically fling heavy droplets of water away from the outer guard hairs. Then, they begin the vital process of reapplying specialized oils. Through the repetitive sweeping motions of their paws, They stimulate the sebaceous glands located at the base of their hair follicles. These microscopic glands begin to actively secrete a unique, naturally produced lipid, heavily rich in squalene. Squalene is a highly hydrophobic hydrocarbon, meaning it aggressively repels water molecules. By slowly and meticulously rubbing this squalene-rich oil across their entire body, from the tip of their nose to the heavy base of their tail, the otter systematically reseals its waterproof armor. This step-by-step application ensures that the insulating layer of dry air remains perfectly trapped against their skin, guaranteeing warmth throughout the cool, still night. With their fur thoroughly conditioned, the sequence continues as the otter navigates toward the hidden entrance of its holt. They move through the final stretch of water and climb the sloping subterranean tunnel. Inside the main chamber, the process of constructing a microclimate begins. The earthen floor is carefully lined with dry vegetation, frequently utilizing species like Phragmites australis, the common reed, or various desiccated wetland sedges. When a family of otters settles down onto these reeds, they engage in a specific behavioral process known as thigmotaxis, which simply means an attraction to physical touch. By continuously shifting and nestling tightly against one another, they form a dense interwoven pile of sleeping bodies. This step-by-step arrangement is mathematically brilliant. By huddling together, the otters systematically reduce their collective exposed surface area by up to 40%. As their metabolic furnaces continue to gently radiate warmth, that heat is immediately captured by the hollow tubular structure of the dried reeds beneath them, slowly elevating the ambient temperature of the small enclosed chamber until it becomes a perfectly insulated, incredibly cozy haven. Internally, the physiological transition into sleep unfolds with beautiful, calming precision. In the otter's autonomic nervous system shifts control. Throughout the active day, the sympathetic nervous system drove their energetic foraging. Now, the parasympathetic nervous system, the network exclusively responsible for rest and digestion, smoothly takes dominance. Observe the sequence within their cardiovascular system. The vagus nerve, a major neural highway, running from the brainstem to the abdomen, begins to steadily secrete a neurotransmitter called acetylcholine. This chemical binds directly to the pacemaking cells located in the sinoatrial node of the otter's heart. Step by step, beat by beat, the release of acetylcholine physically slows the electrical impulses governing the cardiac muscle. Their heart rate, which hovered at a rapid 130 beats per minute during their evening swim, gradually decelerates, dropping down to a slow, rhythmic, and incredibly steady 60 to 70 beats per minute. As their breathing shifts into a deep rhythmic pattern, driven entirely by the slow rise and fall of their diaphragm, their sensory equipment gently powers down. The tiny sphincter-like muscles located within the auditory meatus of their ears, which remained tightly clenched to keep water out while swimming, finally relax completely. The pressure drops. Simultaneously, the steady flow of blood rushing to the follicular sinus complexes, the hydraulic capsules surrounding their sensitive facial whiskers, begins to steadily decrease. As the internal fluid pressure within these microscopic capsules subsides, the stiff vibrissae become desensitized. The constant, the overwhelming flood of tactile information that bombarded their brain all day is smoothly and effectively muted, wrapping their mind in a profound, peaceful silence. As the otter crosses the threshold into the first stage of slow-wave sleep, cellular restoration actively begins. The lymphatic system, an intricate network of vessels running alongside their bloodstream, quietly goes to work. During this deep state of rest, The lymphatic fluid continuously circulates through their heavy epaxial swimming muscles, systematically gathering up the accumulated lactic acid and metabolic byproducts generated during their hours of continuous motion. This slow, methodical clearance guarantees that their muscles will be fresh, loose, and completely restored by morning. Simultaneously, within the intricate folds of the sleeping otter's brain, a remarkable process of memory consolidation unfolds. Neurological studies demonstrate that during this slow-wave sleep phase, a seahorse-shaped structure, called the hippocampus, actively replays the complex spatial maps the otter navigated earlier in the day. The brain gently fires the exact same sequences of neurons used to memorize the location of a sunken log or a particularly rich patch of riverbed, physically encoding these daily experiences into long-term, permanent storage. When the otter eventually cycles into REM, or rapid eye movement sleep, a final protective mechanism engages to ensure they remain perfectly still and safe while their brain generates vivid internal imagery. The brainstem sends a localized inhibitory signal down the spinal cord. This signal triggers a temporary, harmless state known as muscle atonia. The heavy muscular tail completely relaxes. The powerful webbed paws go entirely limp. The otter is held in a state of absolute physical tranquility, securely cradled in the warm darkness of the holt, completely surrendered to the natural, restorative process of rest. We can gracefully follow this same, gentle sequence within our own bodies. The busy, active systems of the day are no longer required. The light has faded, signaling the mind that the time for effort has passed. The transition to stillness is a natural, biological process, unfolding exactly as it should. Notice the gentle deceleration of your own rhythm. The pace of your breathing naturally slows, matching the calm, unhurried cadence of the sleeping otter. With each exhalation, the intricate network of muscles along your spine, across your shoulders, and down through your limbs begins to release its stored tension. The physical requirement to hold, to move, to navigate simply dissolves. The senses turn inward, muting the external world, allowing a quiet, insulated space to form deep within your awareness. You are moving smoothly through the stages of settling, supported by the quiet gravity of the earth, entering a state of absolute, profound repair. I am at peace. My body knows exactly how to rest. I release the efforts of the day. My breath is a slow, steady rhythm. I am entirely safe in this quiet moment. My muscles soften and let go. I embrace the calm of the evening. Every cell in my body is naturally restoring itself. My mind is clear, quiet, and still. I am surrounded by comfort and warmth. I surrender to the gentle pull of sleep. My thoughts drift like slow-moving water. I am perfectly supported. I welcome this deep, healing tranquility. The world outside is resting, and so am I. I sink comfortably into the quiet darkness. I am deeply relaxed. Good night.